Hello, candidates. Very good evening to all of you. This side Ankit. So let's just start. Guys, am I audible? Just let me know. I'm sharing my screen. Hello, Tarun, Vaishnavi, Nisarg, Preeti. I hope everyone is doing well, candidate, right? So I have already started my recording. Let me just share my screen. Okay, audible. Perfect. Okay. So guys, in the last class, what we have completed, we have started the Streamlit introduction. And with the help of Streamlit, we have deployed the project as well, right? I have already shared you the link of that project where you can simply use the Streamlit and you can deploy your project, whatever the project that you are going to create or whatever the project that you will create from your side as well, right? You can simply deploy all those projects using the Streamlit and you can simply show that project to the client or to the interviewer, like whatever the company that you are applying for, right? Okay, so today onwards that we are going to start is introduction of a deep learning, right? Then we'll understand the different types of deep learning techniques. We will try to implement the same thing. Then we will complete the final project. It is some sort of like the combination of both machine learning project and the deep learning project, because we have the data set, and based on that data set we'll try to implement the machine learning model as well as the deep learning model, right? So let's just go to Google Colab. Okay, what I'll do, I'll just simply start with the basic introduction of a deep learning, right? So let me just go to the new notebook. Okay, well, there is no requirement of a notebook right now, but if we want to perform some sort of basic coding, then we can simply perform it, right? Okay, so we already know that, candidate, if we have a like structured data, the structured data is some sort of like we have a fixed number of rows and the fixed number of column, right? So let me just write this. If we have a structed, if we have a structured data, then we can use the machine learning technique. Inside the machine learning, the data set is limited, right? If someone is asking you like when to use the machine learning and when to use deep learning, so in machine learning, data set is limited and features is also limited. Okay, data set and features is also limited, and it performs well when we have a limited number of features and the limited number of data. Okay, now when the problems arise, it's like when we are getting the multiple data or like the multiple features, it's like multiple data or multiple features. Okay, then we have to use a deep learning. Now let me just show you what exactly the deep learning is. So what about the structured data, right? In the structured data, we generally know that the data is stored in a form of tabular format, right? Tabular format data, it is like in a rows and column format. Perfect. That is my structured data. And where we can use this machine learning, right? Now, what about the unstructured data? The unstructured data, which is stored in a form of file format, right? Unstructured data, which is in a file format. And the file format is something like file format, or you can say it's generally stored in a folder format. And the data set like this, image data. Okay. You can have the audio data. You can have the video data as well. Okay. It can be like related to multiple set of audios, MP3 videos file. It can be like this. Okay. So if you are getting any sort of data like this in this format, unstructured data, these data are generally represented by the unstructured format. It's like in the file or like a folder format. So we have like the n number of features. The features are not limited here. The features are not limited. And if we are not having the limited feature, so we have to use some sort of different techniques. Machine learning can be useful if we have a limited features, right? But when we have unstructured data, inside this unstructured data, we don't have a limited features. We have an n number of features, right? So we cannot use the machine learning, right? Because machine learning generally based on the equation of line, we know that, right? Y is equals to mx plus c, okay? And x generally represented by the number of features like x1, x2, x3, and x and so on, right? But what in case if we want to train a model, and the model should be like automatically understand the pattern, and based on that it it predicts the value, right? That is a sort of deep learning technique. Okay, so deep learning generally we use when we are getting the unstructured data, image data, audio data, video data, and some sort of like time series data as well. Okay, well, time series is not a unstructured data, it is a structured data, but just for use case I'm writing this. If we are getting the time series data now, we have to use the deep learning, right? So the data set is very huge. You can just write this. The data set is very huge in size. Okay. So there is a very popular graph, and that graph is something like this: ML versus DL, data versus accuracy. Okay. This one is very popular graph. Let me just show this. This one is perfect, right? Okay. When we increase the size of data, na candidate, it's not opening. Let's just use this one, right? Okay. When we increase the size of data set, this is the amount of data and this is the accuracy that we are getting. Okay, when we increase the amount of data, machine learning generally perform well, right? But once you try to increase the amount of data like in very huge amount, so you will always get the same set of fixed accuracy. If you just keep increasing your data like very big amount, so your accuracy will not going to be improved, right? You will get a constant static line, right? That is the major problem with the machine learning. That is the role where deep learning you can use, right? Deep learning is like the more you can give the data, the more amount of data that you are giving, it will try to improve the accuracy again more side, right? So deep learning and machine learning, both, if you are giving the common data or like very less amount of data, it generally behaves same, right? But if you're getting the good amount of data and if you're keep increasing the amount of data, it generally prefer to use the deep learning, because deep learning can tackle the multiple features, can easily understand the unstructured data, whereas machine learning can only work with the structured data or with the limited amount of data. If you try to increase the amount of data as well, so the accuracy will remain same, right? This is the very popular graph, so let me just copy this and you can just paste it here, right? Because generally it is asked in the interview like when to use the machine learning and when to use the deep learning, right? Okay, now just simply understand we have to deal with the unstructured data now. So that is the reason AI is generally divided into broader terms, right? If someone wants to get into this AI now, they need to first start with the machine learning, and if they're good to go with the machine learning, then they have to start the deep learning techniques, right? And deep learning is just nothing, it's a collection of neural networks, right? We have to build a neural network in such a way that the neural network automatically understand the pattern and it can analyze the data and it can particularly predict the value. We have to mimic the human intelligence with the help of a machine intelligence, and there we generally use this technique which is called the deep learning or like a neural network technique. Okay, now let's just understand what exactly inside the deep learning we have to perform. Okay, so deep learning is general further divided into multiple networks, right? So when someone asks you what do you understand by deep learning, what is the meaning of deep inside this deep learning, right? We have different nomenclatures for that, right? So if someone is asking you now deep learning, what is deep learning, you can just simply refer this inside a deep learning. It's a subset of machine learning or like a sub branch of AI where we need to where we can mimic the human intelligence, the way human intelligence works, like depending upon the neural network. In the same way we try to build the neural network. And what exactly the neural networks, the neural networks are consecutively the collection of multiple neurons. These are the multiple neurons where each neuron is responsible for getting some features, whatever the input data that has been given, right? Okay, now let's just understand the basic difference between machine learning and the deep learning again, right? Okay, so in the machine learning, we will get the data. A user or like a ML engineer have to perform the feature extraction task. Understand this concept, candidates, right? After getting the important feature, you will create a model, right? The model could be regression problem, the model could be classification problem, right? Whatever the model that you have created, you will feed out the data. That model will try to extract the data or like the features, whatever the data that has been given. Okay, and the model will try to analyze the values or like predict the values, and then it will finally give you the value, right? This is the traditional way of machine learning, right? But in deep learning, there is no extra additional use case of feature extraction. Okay, if you just simply combine the feature extraction and the model itself, the model become itself a deep learning. It's kind of a deep neural network, right? Where you have to just simply give the data, you have to create some sort of model, and each model is responsible, is a collection of multiple neurons, right? Each neuron is like some sort of mathematical function where it will eventually try to understand the data behavior or data pattern, right? Once it totally understand the data behavior or like the data pattern, then the each interconnected node is responsible to communicate with their corresponding node and finally transfer the feature to the output, right? And the at the end of the output, you will get the final value. The final value could be like the regression problem, or like it could be the classification one. And inside the classification, it can be binary or as well as the multi-class classification, right? I hope everyone already aware with these terms, right? Okay. So inside deep learning, we generally know that, okay, what we have to do, we have to simply create a neural network, right? Okay. Now let's just understand what exactly the neural network is, okay? And how to simply decode this neural network in a very basic or like a meaningful way with some sort of mathematical intuitions, right? Okay. So when it is like comes to deep learning, na, inside deep learning, we have to create a neural network, and deep learning is further divided into three different neural networks, right? The first one is called ANN, second one is called CNN, and third one generally is called the RNN. These are very popular neural network models inside deep learning. We generally have to understand, and once you are good to go, believe me, candidate, you can easily tackle any of the or like most of the data set or unstructured data set that you are particularly using in your day-to-day work, right? So ANN, CNN, and RNN are three mainly broader classification of a deep learning techniques, right? Now let's just understand the meaning of ANN, CNN, and RNN. ANN is like a artificial neural network, right? It's an artificial neural network. The CNN is generally referred as a convolutional neural network. Whenever you are getting the image data set or like a kind of video data set, then in that case you have to use this model, this convolutional neural network. I'll definitely explain you what exactly this convolutional says, right? So whenever you are getting the visual information or like the image data, like the video data, understand one thing, you have to use this deep learning technique, and inside this deep learning candidates, you have to use the convolutional neural network, right? Okay, now what about the structure, like what about the time series data or like a set of contiguous data if we get, right? Like the natural language processing kind of, because we know that deep learning is very popular when it comes to the natural language processing or like LLM models, right? So there is final technique which is the very popular inside the deep learning one, that is called the recurrent neural network. Recurrent neural network is very popular when you have a sequential data. The sequential data can be like the time series data, it can be like the natural language processing data, it can be like some sort of any data that has been in a sequential form, right? So you have to use this RNN concept, and all these ANN, CNN, and RNN, the NN word generally is like neural network, right? And you have to understand what exactly this neural network is. Okay, so I hope everyone is clear with that. Deep learning generally comes with three different neural network. The first one is called the ANN, second one is called the CNN, third one is called the RNN. ANN is like artificial neural network, convolutional neural network, and recurrent neural network. Okay, so let me just quickly write this one: ANN, CNN, and RNN. Okay, so it's like when you have, you can use this ANN for any task of ML. Just believe me, candidate, right? ANN is like you can simply replicate any machine learning model with the help of artificial neural network model, right? Where in this artificial neural network, now you don't need to create like a model again and again. What you have to do, you will just simply construct the set of neurons, right? You will decide the number of neurons, and each neuron is responsible to extract some features, to extract some information, patterns, data from the given input of the data, right? And then it will decide the final predicted value. Okay, so you can simply replicate any ML task with the help of ANN, right? Deep learning is further extension of the machine learning, right? So you can use any task like it for the classification one, or for the regression problem as well, right? Suppose you want to predict the sales, you want to predict GDP, you want to predict like some sort of the disease, okay, and etc. Anything, then you can use this artificial neural network, right? But what in case if you're getting the image data set, then you have to use this one, which is called the CNN. CNN is not a news channel, it is a convolutional neural network, right? And when you have the image data set, right? When you have like the video data set, then you can use this CNN. CNN is very popular amongst the engineer that they generally use for the video streamings, so and so on, right? I hope everyone has seen this kind of like, this is called the bounding boxes. Let me just show this, right? I hope everyone has seen this kind of images, like once in their lifetime, right? I hope everyone has seen this kind of images, right? So if you want to do perform tasks related to this kind of na, so you have to start this technique that is called the convolutional neural network, right? In this we have different modules. We can use OpenCV, we have YOLO modules, right? We have multiple open source module candidate. Believe me, if you actually wants to get into this artificial intelligence field na, you have to be very good in the deep learning, right? Machine learning is the fundamental concept. It's called the statistical learning of AI. It's like it, it is a statistical kind of something, right? When it is comes to practical implementation, deep learning comes to the market, right? You can solve any sort of problem, whether it is like robotic learning. If you want to design your robot, if you want to design any sort of IoT device, instead of machine learning na, because machine learning is some sort of like a statistical kind of thing, right? You have to build a neural network, and believe me, this is crazy thing, right? So image data set, video data set, then you will probably use this convolutional neural network, right? Now what about the RNN is like the recurrent neural network. And when you are getting the NLP task, it's like a language problem, language data set, okay? Suppose you want to create a model, and the model is like generally takes the French as input and English as the output. So French to English translation, you have to use this RNN technique, right? It is generally useful when you start the any NLP task. So RNN is very important, right? It is again very helpful when you have the time series kind of problem. And if I say time series kind of problem, generally we refer this as a stock market analysis, right? Stock market analysis or some sort of like share price prediction. Okay. So class, then in that case, you can use this RNN concept. RNN is like recurrent neural network, right? CNN is like convolutional neural network, and ANN is like artificial neural network. Now we know that we are using again and again like neural network, and neural network. Now let's just understand what exactly this neural network is, okay? So NN is like a neural network, and neural network is, believe me, candidate, in the previous days, scientists were thinking, na, okay, the machine, if we want to train a machine, we have to design the algorithm, so and so on, right? The traditional way of programming is called the algorithm designing. The AI way of programming is called just a neural network creation, right? Where you don't need to design the algorithm. Believe me, candidate, you have to create a model. A model eventually try to learn from itself. Okay, you're not allowed to create a mod like the any sort of algorithms, whatever the algorithm, it's like binary algorithm, binary tree, searching, sorting algorithm, any sort of algorithm, right? This is the traditional way of programming. And when it comes to machine learning and deep learning kind of thing, you're not allowed to create the algorithm. Whatever you are creating, it's like the neural network. That network is responsible to understanding the pattern, and based on that pattern it will predict the values, right? So scientists were also want to like create that kind of human mimics, right? Where they can mimic the human brain. So that is the reason they have started with the same concept with the human brain, that is called the neural network. What is neural network? A neural network is just nothing, a collection or combinations of, okay, let me just write this, collection or combinations of neurons in a consolidated way. Yeah, in a consolidated way, it's like you are particularly creating a model which is a collection or like a combination of multiple neurons, and each neurons is connected with their corresponding neuron, and finally it create a model, and that is called the neural network, right? So it's like some sort of this kind of figure, right? Okay. I'm just simply keeping this figure, right? Where you're getting some input data and you will create some sort of different neurons, right? And it is finally interconnected with the output one, right? Now let's just try to understand what exactly this neuron is and how this each neuron is responsible to get some features from this data set, right? So we will pick the same iris flower problem, then you can relate, okay, this is the neural network, right? Okay, now let's just understand. Inside this iris flower candidate, we know that we were having the four different features. It's like sepal length. Okay, so let me just quickly write this. Sepal length, okay, centimeter, sepal width, centimeter, petal length, and petal width, centimeter. Okay, we have already used this like in our ML class, right? So we are having the four different features. Okay, now let's just consider this each feature as a single neuron, right? So we will just create a single neuron for each individual. This is like neuron 1, and let me just create a copy of this so that the size will remain same. Control C, Control V. This is like your neuron 2. Uh, Perfect. Neuron 3, let me just paste it here. Each neuron is responsible for some sort of feature extraction and some sort of analysis, right? And this is the neuron 4, right? Perfect candidate. Why we are considering the four neuron at input candidate? Because we are having the four features, right? Now this each features will be input by the input will be given inside this each neuron, right? So let me pass the input of sepal length here. These are my input part, sepal width here, petal length here, and petal width here. Okay, perfect. Now we know that at the output of this, we want to create the model. The model is like it will generally predict the classification part. It is like Setosa flower, versicolor flower, or like a Virginica flower. Everyone already aware with that, right? So now let's just we know that because we are having the three different outputs now at the final output. So let's just simply consider this as three output. First one, second one, and the third one. Okay, third one. These are my final outputs, right? Okay. Now we have this input, we have this output, and we know that the each output is like the different flower name, and it is like Setosa. The second one is like versicolor, and third one is like Virginica. Okay, perfect. We will get the input from this input neuron, we will get the output, and the output will be decided by some sort of probabilistic function, right? Okay, now what about this input and output? Like this is called the black box area. Okay, candidate. Now inside this black box, this is called the magic part, where you have to understand what exactly inside this. Okay, just for sake of understanding na, we have to design some individual neurons. We have to pass some individual neuron where each neuron is responsible to extract some information from the given input, right? And this internal part is called the hidden layer, right? So what I'll do, I'll just simply copy and paste the each neuron, right? Part 1, part 2, and part 3. Let me just paste this. The part 3 is enough, right? And I'll quickly copy all three parts. Let me copy the all three part. It's not getting it perfect. So let me copy this. Now it's perfect. Control C, Control V. Okay. And these are like my each circle, na, candidate, each circle is a neuron, right? So let me just paste it here. Each circle is a neuron. And it's not recommended to use the four one. It's not like we are getting the four features, then we will use the four neuron at the each like hidden part, right? It's not the same one, right? But if you're getting the four input now, so it should be four input at the like four neuron at the input part. Now what is the case, each neuron will be connected to their corresponding neuron. Okay, so whatever the output that we will get, it will be passed through this input, right? And same as it is, whatever the output that we will get, this will be connected to this one, same as it is with this one. and same as it is with this one. Okay, where whatever the output that we are getting from this input candidate, it will be connected to the each neuron part, right? Okay, now repeat the same case with this one. Okay, I'm changing the color so that you can relate this, right? So whatever the output that you will get, you again it will be connected to the each individual one, right? The third neuron and with the fourth neuron, right? Perfect, like this. Okay, same, repeat the same step. Whatever the output will go to this neuron 1, the output will go to this neuron 2, the output will go to same with this neuron, and same as it is with this neuron, right? So now let's just understand where each neuron is connected with their four. So it's like the four lines. Okay, second, again, this one is also connected with 4. So it's like 4 plus 4, same as it is with this one 4, and same as it is with this one 4. Okay. So this is like some sort of the parameters, right? We generally refer this as a different weights, right? Again, this will connect it to this one, then again follow this one. Okay. Each circle is like your neurons candidate. Okay. Now I'll simply explain what exactly the neurons are. Okay. Now let's just understand this is like the neuron, and we simply refer this neuron as a neutron, right? Okay, it is responsible to take the input, do some calculation. I'll let you know what exactly all these calculations are. It will do some calculation, just understand, and it will give some output at the final value, right? And whatever the output that you will get, it will again go to their corresponding neuron, and it will become the input for this neuron, right? And whatever the input that we will receive, then it will give some output, and each output will connect it to this one, right? Now let's just understand, these are four neurons. Okay, and each four neurons are connected with their four corresponding neurons. So the overall connections that we will get, 4 into 4 into like 4 plus 4 plus 4 plus 4, so it's like 4 into 4. Can I just say this, the connection that we are getting here, it's like 4 cross 4, right? Four neuron is connected with their four neurons, so it's like 4 into 4 weight. We will get the matrices of 4 into 4. Let's just increase the size like this. Okay, now you have to repeat the same process again and again. So let me just quickly do this, right? Now this output will be connected to its input, same as it is its output connected to this input, same as it is with this one, and same as it is with this one, right? Okay, now you have to repeat the same step. This its output is connected to another neuron, same as it is this neuron, same as it is this neuron. Now you have to understand in this concept candidate what is output, right? And what is exactly and why we are connecting and why we generally took this neuron as a random neuron, right? You have to understand this concept, right? Okay, same output will be connected to like this, same as it is, just connect this to this one, connect this neuron to this one, connect this to this one, and same as it is, connect this one to this one. Now we will get the same as 4 cross 4, right? So it's like 4 cross 4 or 4 cross 4 of matrix we will get here, right? So you can just simply say this, right? Okay, now just repeat the same step. You can just change the color of this one. The output of this neuron will be connected or like will be behave like the input of another neuron, same as it is output of this one will be connected to like input of this one, and just repeat the or like reiterate the same steps, right? Just repeat the same step with this one. Output will be connected to this neuron, same as it is this neuron, and same as it is this one, and same as it is with the last one, right? Now let me just do it quickly. The output will be connected to this one. Once you understand this now, candidate, believe me, this is the crazy thing, and then you can probably understand the deep learning concept, right? Because these deep learning is exactly the neural network concept, and if anyone is walking in this concept now, machine learning, deep learning, or data scientists, they generally understand this concept, right? Again, we will get the 4 cross 4 of matrix, right? These are like my parameters. Okay, if anyone is asking now the number of parameters that the model is trained on, this is called the parameters, right? Okay, now just simply connect. Okay, why we are taking the output as the 3 neuron? Can anyone say this? Why we are considering the output as 3 neuron, candidate? Just write down in the message area, or you can simply write down your comment as well. Why we are connecting each neuron with the 3 output, and why we are taking the 4 neuron at the input? Can anyone wants to say something in this? They can turn on their mic as well, or they can let me know, or they can simply write in the message area, right? Now let's just connect this neuron to this one, this neuron to this one, and this neuron to this one. Now, can anyone let me know what is the matrices here, right? Here we are getting 4 cross 4, 4 cross 4, 4 cross 4. What is the matrix that we will get at the output candidate? Anyone? Tarun, Sneha, Spurti, and the rest candidate? We will get the output is like each neuron is connected with the neuron. Na? So the weight matrices will be like 4 cross 3. Okay. Now let's just understand this is called my neural network. Okay, and inside this neural network candidate, this area, let me just shade this area, right? This area is called input area. This is called my input area. Okay, the yellow area is called the hidden layer, and the light blue area is like your output area. Okay, let me just write this one is like your input. Let me just pick this color. Input neurons, input NN. Okay, input NN. All this red area is like your input NN, and this yellow area is called the hidden layer. Hidden NN. Hidden NN is like the hidden neural network, and this one is like the output neural network. It's like output NN. Okay, it's like the output. Let me just write it again. Output neural network. See, this input area is generally decided by the number of input that you are getting. Okay. This is called the hidden neural network candidate. And inside this hidden neural network, you can pass as much neuron as you can, right? Right now, we are just passing 1, 2, 3, and 3, 4, 12. Right now, we are passing the 4 neurons here, right? Inside this hidden neural network, you can decide the number of neural networks. You can decide the number of neurons, right? Where each neuron will be connected to their subneuron or like the interconnected. They all are interconnected together, right? And this will be like your output neuron candidate. I hope everyone is getting my point candidate. And the combination of all this input neural network plus hidden neural network plus output neuron is finally your artificial neural network. Let me just write this. Then you can say this as a artificial neural. This is like your artificial neural network, and in short, we generally refer this as a ANN, right? So this is like your ANN. Okay, you can decide this hidden neural network, and why we are considering this as a deep learning, why we are referring this topic as a deep learning, because we will create the dense layer. This is called the dense layer. We will create the dense neural network. See, all these interconnections are like dense connections. Just look at this now. 4 into 4, it's like 16 weights. 4 into 4, it's like 16 weights. 4 into 4, 16 weights. 16 weights plus 16 weights plus 16 weights. Okay. And then 4 into 12. It's like the overall weights that you will get is like all these weights are called parameters, right? So it's like 16 plus 16 plus 16 plus 12. And you can just do the calculation. See, it's like 16 threes are. Just do the calculation. It's like 16 into 16, and it's like 16 multiply 3. Okay, 3 6 is 18, and 16 is 48, right? And plus 12. So it's like 48 plus 12 is equals to 60 parameters that you will get, right? Can you just look at this? We are getting the 60 parameters, right? 3, 6, 18, 48, and 48 plus 12, 8 to 10, 5, 1, 5, 4 or 1, 5, and 60. So these are called the 60 parameters, right? And just look at this. This is called the 60 parameters. See, I am referring this word as the 60 parameters, right? Now, if anyone is saying this now, Chat GPT, let me just write this on. Chat GPT is trained on how many parameters? Now just look at this. We are just creating this 60 parameters models, right? Where where the neural network is trained on the 60 parameters. The 60 parameters is like 60 connections that they are forming, right? Now just look at the magic inside the Chat GPT. The Chat GPT 3.5, initially it was trained on 175 billion parameters. Now just look at this complexity or like the vastness of this model, right? Chat GPT-4 around particularly trained on 1.6 trillion parameters. Right now, we are having just only the 60 parameters. Just look at the magic of this, right, candidate? Okay. And Chat GPT 4o or Mini, it's particularly trained on 200 billions parameter or 8 billion parameter for the mini version. Okay. You can just go and check about the Gemini as well. Gemini is trained on how many parameters, right? You will get the answer, right? So Gemini Nano 1.8 billion parameter, Pro 500 billion parameter, 2 and 7 billion parameter. Just look at the vastness of these trainings, right? That is the reason if someone wants to create their model from scratch, if we are just creating this model, just Sitosa or like versicolor and Virginica prediction, we have to train our model with the parameters of 60, right? And if we want to mimic the model of like Gemini and like the Chat GPT, we have to train our model at the 500 billions of the parameter, right? That is the complexity of that model, right? And that's where the GPUs came to the market. If you want to train the model so much amount of data, so much complexities of parameter, you will cannot particularly train your model using the normal CPUs. Either you need GPUs or you need NPUs or like the TPUs, right? TPUs are called the tensor processing unit. Okay, Google has the TPU. Okay, Google designed this TPU, and the tensors are nothing. Tensors are just the higher dimensional arrays, and higher dimensional arrays are like very complex arrays that you want to process. NVIDIA has the GPU, right? It's like the graphic processing units, right? So either you have to use this GPU or you have to use the TPU, right? We have another PUs that is called NPUs, right? The interviewer also asked this one, right? NPU versus GPU versus CPU versus TPU, right? These are interconnected, right? NPU is like the neural processing unit, right? Where the upcoming laptops are already, their chips are already trained on the neural processing, right? So these are called the NPUs, right? So just look at the vastness or like the complexities of this kind of model, right? Now we understand, okay, the ANN is like the artificial neural network. Now, what about this neuron is? Okay, so this neuron is just nothing. It's a mathematical form, it's a mathematical formula or kind of mathematical function. Now let me just represent this what exactly this is. Okay, so I'll just increase the size of this canvas. Now let's just quickly zoom in what exactly a single neuron is. Okay, so the topic is what is single neuron. Okay, whatever the neuron that we are creating now, okay, the number of neurons is like 4 4 4 4. It's like 16, and 16 plus 3, it's like 19 neurons. Okay, what is neurons, right? What is neuron and what are different neurons, right? So if you want to understand this one, so let's just simply zoom in one neuron, right? So what I'll do, I'll just simply pick this circle or any of the circle and let me just simply explain this. Okay, this is like a single neuron. Okay, what is a single neuron? So this is like a single neuron. What exactly this single neuron takes? You know that the single neurons takes as one input as much as can, and the multiple input as much as can, right? If it is a part of hidden neural network, it can get data from multiple neurons. Now just look at this vastness. If you are creating the thousands of the neurons, so definitely it can take thousands of the inputs, right? So it's not like just getting the single input. It can take multiple inputs, right? Let me just write this. It can take multiple inputs. Input 1, input 2, input 3, input 4. Okay, just for understanding now, because we have used the sepal length, sepal width, petal length, and petal width, so I'm just referring the 4 inputs, right? Okay, now this single neuron is divided into two parts. Okay, let me just create a line here. The single neuron is divided into two parts. The first part is called this left part is called the summation part. Okay, this is called my summation part. Summation part. Okay, now what about the, let me just write this again. This first part is called summation part. Okay, and I'll quickly explain this what exactly the summation part is. And this second part is called the activation part, right? This is again the same behavior of a human neural network, right? This first part is called the summation part, second part is called the activation part. Now we know that we are getting the features from different flower, like the iris flower species. Okay, and we know that the sepal length is like my x1. Okay, this is like what is this? This is like your x1, right? So you can just simply write this as x1. Okay, let me just change the color or increase the size bit one. Okay, this is like your x1, x2, x3, and x4, right? Now you know that. So we will get the same x1 here, x1, x2, x3, and just follow the same step. It's like x4, right? These are like my features, input features, right? Perfect. Now you know that, candidates. Just recall the same concept that we have used inside the linear regression. Now we know that this x1, the input of this x1 will be given to this input neuron, right? So it will use the same equation of line, or like the same y prediction function. And we know that the basic y prediction is like y is equals to mx plus c, where x is like the input features and c is like the bias, right? We already knew that, right? Now we can also say this y is equals to instead of w, we already know that we can simply refer this as weight into x, and instead of c we can refer this as a bias, right? We already knew that, candidate, right? So this x will be given to this input, and if you want to like particularly predict any value, so you have to apply some weight here. So let me just write the weight 1 for this x1, weight 2 for this x2, weight 3 for this x3, and weight 4 for this x4, right? And you just need use the equation of line, and we know that if we are getting the multiple features now, so the equation of line will become like this: y is equals to, or like y prediction is equals to, we are not only getting the w1 feature, we are getting multiple features, so the equation will be like this: w1 into x1. X1 is like weight 1 into w1, okay? Same as it is w2 into x2. X2 is like for the second features. Same as it is w3 into x3, and then follow the same concept w4 into x4. What we are doing, candidate, we are just summing up all the values and then finally the bias value. And we know that bias is nothing. Bias is just like when the all x values are 0, then the y will become the b. That is called the bias. We are just summing up all the values, candidate. Y is equals to w1 into x1 plus w2 into x2 plus w3 into x3 plus w4 into x4 plus the b. Because we are summing up all the values, so that is the reason we are referring this as a summation part, right? There is no another things that we are calling. Why we are calling this as a summation part? Because we are taking input, we are applying some weights, right? W1, it, and all the weights generally depends upon the number of features. If we are getting features up to xn, so their weight will become wn, right? You know that. Perfect. Okay. Now, because we are summing up all the values, that is the reason we are saying this as a summation part. The first part of this neuron is called the summation part. Now, what about this activation part? Now just look at this condition. We have already used this. That is called the logistic regression. Inside the logistic regression, candidate, we already knew that. Let me just write this. Logistic regression. Inside the logistic regression, we will use the sigmoid function, right? What exactly this sigmoid function behaves? It just simply takes linear data, it takes linear data and give output value to between 0 to 1. We know that, right? It gives output value between 0 to 1, right? And it's neither 0 or nor exactly 1. It is between the 0 to 1 value, right? So we have this sigmoid function. Let me just change the color of this one. We have this sigmoid function, okay? And this sigmoid function, generally what it try to do, it generally takes the linear data and give the value as between 0 to 1, right? What we know that, candidate, we want to use this function is like the activation part. The activation part is like whether this neuron is particularly responsible for any feature extraction or like for any sort of operations or like any sort of process. If it is responsible, so the output value will be 1. If it is not responsible, for the output value will be 0. And you know that the sigmoid function, what exactly the sigmoid function takes? Let's just go to Google and simply write this sigmoid function. Sigmoid function generally takes the value as y, right? You can just simply you can just pass the value like this. Okay, let me just copy this image. This sigmoid function generally takes this y value, right? This is the equation candidate, right? It will take the value of y, and let me just paste this image here. This is called my activation part, right? So what it will do, it will just simply take the take the value of y and pass inside this activation function, or like inside this sigmoid function. Okay, now inside this sigmoid function, you know that it convert the value between a range of 0 to 1, right? And you will get the final output either on 0 side or like on 1 side. This is called the sigmoid part, right? And this is like your activation function. So whatever the summing up value that you are getting, you will pass all the values inside this equation. And you know that this equation only gives two output, either close to 0 side or close to 1 side. It is generally decided by the probability value. Like if the value is above the 0.5, so the value will be 1. If it is below the 0.5, the value will be 0, right? And we know that whatever the activation value that we will get, candidate, that activation value is my neural output value. And we know that the value will be either 0 or like 1. So you can just simply write this. Whatever the value that we will get, it is like either 0. Let me just write this. Either it will be 0 or it will be 1. This is the final output that we will get. And this is like my single neuron candidate. Whatever the things that we have particularly performed now, this is called a single neuron. Okay. Let me just write this as single neuron, right? And this neurons is just similar to each and every neuron, right? And whatever the neuron here you are seeing now, this is the each individual neuron, right? Let me just take a screenshot of this. Okay, these are like my each individual neuron where it is responsible to particularly give some output. And let me just decrease the size so that you can relate. Okay, where each neuron is responsible to give some sort of output, right? This is like your neuron. Perfect. And you can just simply place all the neurons and it will give the output, right? So, well, I'll not repeat the step with each and every neuron. It will take some time, right? But just for understanding purpose, I'm just pasting it for some neurons, right? Okay. So can it in this way, you are creating your not the machine learning, like your deep learning artificial neural network, right? And you got to know that the each neuron will generally take input. It will do some calculation. The calculation part is called the summation part. It will perform some sort of summation part with which is followed by the equation of line, then use the activation function, and inside this activation we generally prefer this sigmoid function, and sigmoid function generally takes the linear data and give the output value between 0 to 1. If we are getting the value close to 1, so the neuron is activated. If we are getting value 0, the neuron is deactivated, and each neuron will try to communicate with the each and different neurons, and you will get the final output here, right? Now we need to understand, okay, is there like the only things that we have to perform with the help of sigmoid function? Don't we have like another function instead of sigmoid function? Do we have another functions inside this neural network? Yes, candidate, we do. We have multiple activation functions, and again this is a part of interview questions, right? You have to understand we have different activation function. If you guys are familiar with your 11th class mathematics subject, so you must have heard this term, which is different activation function. And let me just show this. Let me just quickly paste here, right? And we have a list of activation function, and if you want to go deeper inside this deep learning concept now, so you have to must understand learn all this concept, which is called list of activation functions, right? Sigmoid is one of the activation functions, right? But we have like more than 15 plus of activation functions. The popular one are like this, okay? And each activation function is just nothing. It is some sort of mathematical formula that is called activation function. Now why we referring this as activation function? The output will either be like activated or not, right? So these are the popular activation function. Right now we were using this sigmoid function, right? So we have 10h activation function where the output will be in a range of -1 to 1. We have this ReLU activation function where the output will be either 0 or like the max between 0 and the x, right? It can simply eliminate the negative value, right? Inside this 10h activation function, the activation value could be like -1. It could be like on the negative side and could be on the positive side. But when it comes to ReLU activation function, so the maximum value, it could be either 0 or like the maximum of x. Suppose you are getting the x value is like negative. X is not the feature here, candidate. Just understand, x is the output value, whatever the final y that we are getting here. This is called the x here, right? Whatever the x you are getting now, all these are like your y, and y is like the equation of like, right? Here you will not simply consider this as a x. It's like 1 upon 1 plus e raised to the power minus y. And where to get this y? Y is like your summation part, right? Whatever the value that you are summing up, you have to pass inside this ReLU function. The ReLU function we try to identify the maximum value between the 0 and the y, right? And whatever the maximum that you will get, that will be eventually considered as your final output, right? Now, what about the leaky ReLU? Again, leaky ReLU is the mathematical function. Instead of neglecting the negative part, you are considering this as a 0 1. Instead of considering this neglecting the 0 or like the negative part, you are giving some sort of like hyperparameter. This is like the 0.1 of x, right? So either you will get the positive side of x or you will get the 0.1x, right? The maxed out activation function is also there. It's like 1 w1x, w2x, and sort of the bias value, right? Same, we have a ELU activation function, and these are the popular activation function. Apart from this, we have a list of activation function, and if you're applying for like machine learning or deep learning jobs, so you must understand all these activation functions, because this is generally asked in the interviews, right? ReLU activation function, GeLU activation function, pre-ReLU activation function, CeLU, ReLU, right? Swiss function is very important one. Softmax function, you will get softmax function as well, right? Where is the softmax function? See, the softmax function is not written here, but it is important as well, right? Let me just use this reference. Do we have the softmax function here, right? Let me use another one, right? Where is the softmax function? We should get the softmax function as well, right? The softmax function is very important. Why we are considering the softmax function again and again? If we are getting the multiple output, now if we are getting the multi-class classification output, so we have to use the softmax function. Here we are not going to use the sigmoid function. That is the reason I haven't pasted this image here, right? Because we will use the softmax function, right? Softmax activation function. And this softmax activation function is generally based upon the probability concept. A very important one, candidate. Let me just give you the final conclusion. The final conclusion is like, if anyone asks you, what do you understand by deep learning, machine learning, and any sort of learning? It's just nothing. All these are like the mathematical concept, right? What we have just performed, we have simply converted the mathematical part into the some sort of programming one, right? And that becomes the artificial intelligence. If you're not good enough with the some sort of basic mathematical implementation, at least the derivative or like the linear algebra or like the vector calculation, so you will face some sort of problems, right? Otherwise, I'll recommend do some basic calculation. Not I'm like particularly calling or like saying you to, okay, just go and prepare for the IIT JEE mathematics, right? You don't need to do this, right? Just simply take some basic understanding of how exactly all these mathematical polynomial functions are performing, right? We have one more popular function that is called softmax activation function, right? I don't know why we are not getting this one, but this is very popular one, right? And this softmax activation function is generally based upon this epsilon value. And again, I will repeat, this z of I is like the y value. You will sum up all the values, you will get some output probabilities, and the whatever the most probabilities that you are getting, candidate, is the output value for your activation one, right? So this becomes a complete neural network, and a neural network is just nothing. It's a collection of multiple neurons where each neuron is nothing. It's a like a particularly part of two different products. The first one is called the summation part. Summation part is just nothing. It's again the basic implementation of mathematical linear regression, right? And the activation part is just nothing. It's a basic activation functions that we have different outputs. It could be like multiple output, it could be single outputs, right? So this finally becomes into the neural network, and that is the actual neural network into the market, right? Where you will get the input data. Now, the ML engineer has to decide the hidden layer neurons, right? You have to particularly decide the multiple hidden neurons, right? And you can play with that, right? Either you can pick one hidden layer, you can call two hidden layer, you can call three hidden layers, you can call n hidden layers, you can call any hidden layers, right? And it can be decided by the ML engineer or like the deep learning engineer, because or since we are creating multiple hidden neurons or like hidden layer, that is the reason we are referring this as a dense neural network. And because we are referring this as a dense neural network, that is the main reason we are saying this concept as a deep learning. When we are calling this as a deep learning, that doesn't mean that we have to understand very deeply. No, this is not like that. If we are saying this as a deep learning, that means we have to create a dense neural network. You can just simply go and Google, right? What is meaning of deep in deep learning, right? What is meaning of deep in deep learning? It's very easy. It's like the dense neural network. It's like the hidden layers. The more you will create the hidden layers, the more dense it will be. And the more dense layers that you are creating, it's like the deep. That is the reason we are referring this as a deep or like the complex one, right? And that makes this deep learning is like the actual learning of a neural network. The more network you will create, the more complex data it can learn, and more output or more closely output it can particularly predict, right, candidate? Perfect, right? So with the help of this ANN is just the fundamental base of any sort of deep learning. If you're not good to go with the ANN, then you cannot simply understand the convolutional neural network, recurrent neural network, because all this convolutional and the recurrent neural network are just the further extension of the artificial neural network. First, you have to understand the artificial neural network, right? Now, let's just and take any random image, right? Call any random image because everything is similar, right? This is the part of the convolutional problem, right? You are getting the input data in sort of image format. You are creating some sort of neural network where the each neuron is responsible to extract some feature from the input data that has been given, right? And each neuron will transfer some sort of output to their corresponding neuron. Perfect. And you know that the single neuron is generally divided into the two parts. The first one is the summation and second one is the activation part, right? And at the finally output, you will get some sort of probability. According to this image could be zebra as well, this image could be lion as well, but what you will get, the final output is completely decided by the probability. And let me just show you this inside a CNN neural network. And inside a CNN, you can get any images, you can get any image classification, right? Let's just call this one, right? CNN is just like the combination of convolution part plus the artificial neural network, right? I'll definitely let you know more about this in the next class, what exactly this convolutional neural network is, right? So this convolution is a mathematical function, or like it's a mathematical process where you are just extracting the feature from a given input set of pixels of an images, right? Now just simply understand this thing. This is the convolution part of problem, right? And the convolution is simply converted to the ANN part. It's like the artificial neural network, right? Whatever the input data that you are feeding, the data is particularly trained by the model, and the model will understand the final output. Now just look at this. We are using the activation function as a softmax activation, right? And it will give the output in term of probability. It could be 10% raccoon as well, it can be red panda as well, like 20%. And the most probability that you are getting at the output is like 70% for the panda. And that is the reason this deep learning model will simply return pandas as an output, because we are getting the maximum probability to the panda, right? And that is the main concern. If you are using any sort of chat GPTs and any sort of things, it's just nothing. It's a final probabilistic value that has been decided by the model, because we are getting the final value, high probability value on the panda side. That is the reason model is predicting this as a panda. It is not like this is 100% panda. It could be 20% red panda as well, and it could be 10% of raccoon as well. And that makes this neural network is a crazy thing, and it's completely based upon the mathematical implementation. That is the reason mathematicians are still required in the market to simply create all these sort of algorithms and the model, right? So candidate, this is from my side for the today. Well, the today's class is not generally based or to like implement the mathematical or like these sort of practical things related to code part. Today we have just simply understood what exactly the artificial neural network is, and what exactly the different set of parameters. If someone is saying like the chat gpt is trained on billions of parameter, you need to understand that things, right? We simply understood the different set of deep learning techniques followed by the artificial neural network, convolutional neural network, and recurrent neural networks as well, right? So these are from my side, and I think this is enough for today, right? Tarun, very good answer, right? The 4 cross 3 is the final matrix that will be used at the output one, right? Okay. So I hope everyone got this point, and I tried myself to explain in a very detailed way. I hope everyone is getting my point, because if you apply for a ML engineer or like a deep learning engineer kind of things, na, so then they generally ask you what exactly hidden or like what exactly inside the deep learning, right? If someone is saying I have created the artificial neural network now, so what exactly running inside or like under the hood? You have to understand these concepts, right? And that's where a mathematics came into the market, right? So this is from my side, candidate. Let's just complete this for today, right? Let's just keep this for today, and you can just take a reference from the notebook or like the videos that has been shared to you, and let's just connect tomorrow. If you have any doubt, you can just let me know right now, and otherwise I'll close the session. And I think everything is best for the today, right? So Vaishnavi, Karuna, and the rest candidates, class, wish you all the best. Let's connect tomorrow, do more practice, and try to connect with the society or like the market trends, and then apply as much as you can, whatever the opportunity running or like available in the market. Okay, so let's just keep this from my side, and wish you all the best. Connect tomorrow.